Hi, I'm Cal Mitchell, founder of SQL Pipe. I spend a lot of time working with databases, and Amazon Aurora is one of my favorites. The first part of this video explains the benefits of Aurora in plain English and explores how the team at Amazon delivered those benefits. The second part of the video is a demo of my new product, Albatross, where we will transfer a database from SQL Server to Aurora with zero downtime. Yes, that's right, zero downtime. I'd like to mention that Amazon has not compensated me in any way for this video, and my opinions are my own. The three Aurora features I appreciate the most are its high query throughput, its exceptional fault tolerance, and the ability to use Postgres, MySQL, and even SQL Server compatible clients to interact with your data. You can learn a lot about Aurora and its benefits by visiting the documentation and marketing pages for the product. However, to really understand what makes Aurora special, I recommend reading the white paper titled Amazon Aurora: Design Considerations for High-Throughput Cloud-Native Relational Databases. Let's take a quick look at that paper because it does a great job explaining how Aurora accomplishes its high performance and reliability. The paper says in the opening paragraph, quote, "We believe the central constraint in high-throughput data processing has moved from compute and storage to the network." In other words, the Aurora team analyzed the data streams required to create a distributed database and built a custom storage backend that makes use of the unique networking environment inside modern cloud data centers. Phew, that's a lot of big words. Let's look at a diagram. On the left is a networking diagram for a mirrored MySQL database, and on the right is a networking diagram for Aurora. Each arrow in the diagram represents an independent stream of data. As you can see, MySQL requires many independent data streams to accomplish high availability. This represents an opportunity for consolidation. Aurora's diagram shows fewer arrows, which means fewer data streams that need to be serialized, sent across the network, and then deserialized. This is because Aurora distributes the data and achieves a quorum in a more efficient way than MySQL. As they said, the network is the bottleneck at this point, and this is their way of mitigating that bottleneck. In addition to needing fewer data streams, the Aurora team built a consensus mechanism that allows you to minimize query latency while still achieving impressive fault tolerance. If I had to put absolutely mission-critical relational data anywhere, I would probably put it in Aurora. This is not only because of its impressive technology. Other databases offer fantastic reliability at a technical level as well. I just think that Aurora and AWS as a whole is very mature, stable, and reliable, which you can't always say about the latest database startup company. Now that we've covered how Aurora manages to be highly performant and reliable, let's discuss the most unique part of Aurora, and the thing I find most interesting, its client flexibility. I don't know any other database that allows you to talk to it like it's MySQL, Postgres, or SQL Server. It is truly an exceptional value proposition to be able to take any application that expects to be talking to one of those other kinds of databases and consolidate them on a single data source. The possibilities enabled by this are only limited by the creativity of how you want to integrate your data systems. For example, if you have a marketing site running on Postgres and a web application running on SQL Server, you could theoretically combine those data sources in Aurora for analytical or even operational needs. To give a non-technical metaphor, let's say you're taking a guided trip across Europe. Do you want a travel guide who only speaks English, or do you want a travel guide who speaks English, French, and German? All else being equal, I would prefer the one who speaks multiple languages, and that's exactly what Aurora does for you. At this point, we've covered what I think the highlights of Aurora are. Let's move on to the demo to show how you can use our new product, Albatross, to migrate a SQL Server database to Aurora. Albatross works in parallel with Babelfish, a Postgres extension from Amazon that allows it to understand SQL Server queries. Since Babelfish is open source, you can actually run it anywhere, not just on AWS. However, as I think I've made clear, you should definitely consider Aurora as a top migration destination. Albatross has three key features to make this process easier and safer. First, Albatross automatically catches up your Aurora database to your source SQL Server database without having to do any clunky and error-prone manual transfers. Second, once Aurora has caught up to SQL Server, Albatross can cut your clients over from SQL Server to Aurora with zero downtime. Third, Albatross can detect and log any differences in query results between SQL Server and Aurora. We encourage you to run this feature for an extended period before making the final switch so that you have confidence that Aurora is behaving in the way that your clients expect. The benefit of migrating in this way is that you get the immediate financial and technical benefits of adopting Aurora without having to change all of your other code first. Then, once you've made that initial migration, you can reap the benefits of entering the vast Postgres ecosystem. If you would like help with this migration, we also offer professional services to help you get it right the first time. Okay, let's talk about how Albatross works. First, you have to deploy a computer running Albatross. It's best to run it on a Windows toast, but it can actually run on any operating system. You can also deploy it anywhere, so it's possible to run it on-prem to migrate to the cloud, or run it on a cloud-based VPC to migrate providers. Next, you have to create schema generation code using SQL Server Management Studio. Then, Albatross runs Compass, a tool from Amazon that scans your code and tells you what needs to change for it to be compatible with Babelfish. Once you have that report from Compass, you can break the work out into stories or tickets and start assigning them to engineers and DBAs. Don't worry, you get as many tries as you need to get those changes right. Next up is where the magic of Albatross starts. First, Albatross publishes an endpoint and instructs you to point all of your SQL Server clients at that endpoint. It then proxies all traffic sent to that endpoint directly to SQL Server. If you perform a rolling update here, this will result in zero downtime. Once all of your clients are pointing at Albatross's proxy endpoint, the process of automatically catching up Aurora to SQL Server begins. This catch-up process uses a specialized version of our original product's technology, SQL Pipe. It uses a creative combination of transactions and concurrency control to ensure that your databases are exactly equal at the end of the process. Once the catch-up is complete, Albatross begins sending all incoming queries to both databases. The two databases are identical at this point and are being sent the same queries at the same time in the same order. For most intents and purposes, they can be considered logically equivalent. However, Albatross continues to respond to clients with the answer supplied by the original SQL Server database, just to be on the safe side. And that brings us to maybe my favorite part about Albatross, the fact that it allows you to ensure that Aurora is giving you the same answers and behaving in the same way as your original SQL Server database. To do this, once the catch-up process is complete, Albatross logs all incoming queries to a CSV file. It also logs the responses to that query from both SQL Server and Aurora and whether those responses were identical or not. We highly recommend letting this process run for at least a day and inspecting the CSV in Excel or with a Python script to see if there are any meaningful differences between the two database responses. You can run this process in Albatross as long as you want and analyze the CSV file any way that you want to make sure that your new Aurora database is reliable and safe to use, and that it's a valid replacement for the old one. Okay, so now that you understand how it works at a high level, I'm going to quickly demo it right now. Here you can see that I have two databases running in AWS. One is a SQL Server database, and the other is an Aurora database running the Babelfish extension. Please note that Albatross works on any SQL Server database. If I open SQL Server Management Studio, you can see that it recognizes both of these databases as SQL Server. I can also open pgadmin and show that it recognizes that same Aurora database as a Postgres database, which is pretty cool. I'm now going to click through Albatross's UI and explain a few things along the way. The first page instructs you on how to export the DDL code from SQL Server and scan it with Compass. I've already done that in preparation for this video, but I'm going to run a Compass scan anyway to show you what it looks like. As you can see, the report is comprehensive. The parts that I find most immediately important will be labeled as syntax errors or SQL features that are not supported. I don't have any of those errors listed right now because I already made a few alterations to the file, so we can move on. If you'd like help interpreting and altering this file as part of your migration, contact my team by going to sqlpipe.com. Moving on, we can see that Albatross is asking us for connection information for the source and target database. This is needed to perform the query proxying, catch-up, and duplication processes that I mentioned earlier. As you can see, I already entered that information as well, so let's click through to copy over our schema. Now Albatross instructs us to point our clients at the proxy endpoint. I'm going to simulate that by pointing some fake web traffic at Albatross's proxy endpoint. Now we are essentially in the situation described by this slide, where we have a live, active database whose traffic is being proxied through Albatross. Now we can start the catch-up and query duplication process. Because this database is small, it only takes a second. However, it can handle a database of any size. Once that process is complete, I can go into SSMS and run a few test queries. The source database should give me the same answers as the target database, which it does. We can even look in the results comparison CSV file to see if any queries have given us non-identical answers. In this case, I know that these answers are acceptably similar, so the migration process is complete. I could now perform another rolling update to point my clients at Aurora and turn off the source SQL Server database. I hope you've gotten some value from this video. To sum up, Albatross can help you accelerate a migration to the excellent Aurora database from Amazon. Its automatic data catch-up and proxy features allow you to transition with zero downtime. And best of all, it even allows you to verify that your new database is a valid replacement for the old one. Albatross is available now, and we offer service packages to help you complete your migration on time and on budget. Contact my team by going to sqlpipe.com or emailing info@sqlpipe.com. Thank you.